Okay, here we are, 8.2 video notes. We can divide powers that have the same base, and we can find power of a quotient. So just a reminder, when we had the same base and we multiply them, a to the m times a to the n, that was a to the m plus n, right? All right, our quotient of powers property. Quotient means division, remember, so division, right? Let a non-zero real number and let a be a non-zero real number and let m and n be positive integers such that m is greater than n. Just means m is a bigger number than n. All right, before we write that general rule, let's just kind of look at this one. We talked about expanding this. So if I really wanted to, I could say 6 times 6, 6. So if I write 11 sixes up here, probably not the easiest way to do this problem. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 5 sixes on the bottom. 1, 2, 3, 4, 5. So if I have that, what does that really equal? Well, if I just had that, 6 over 6, that's 1. I can cancel that. And cancel these. Cancel, cancel, cancel. There's 1 on the top, 1 on the bottom, I can cancel it. So I canceled 5 on the top with the 5 on the bottom. How many do I have left? 1, 2, 3, 4, 5, 6. So it should be 6 to the 6th. We can do it on our calculator, but we want to know how to work these exponent properties. So what did I really do here without doing all this work? I don't want to write all these out. I had 11 on the top and 5 on the bottom. So since this is division, we did multiplication, we added the exponents. What about subtracting these exponents? 11 minus 5. 11 minus 5 is 6. So that's our rule, actually. A to the m over a to the n is really a to the m minus n. Division's opposite of multiplication. Subtraction is opposite of addition. Okay? So we're going to do it this way. We're not going to write all these out. All right? So let's take a look at this one. Number 2. 1 over y cubed times y to the 8th. Well, I can put that over 1. And y to the 3rd I can put over 1. So I'm just going to rewrite this as one big fraction. 1 times y to the 8th times y to the 3rd. All over y to the 3rd times 1 times 1. Okay, the 1's really don't matter. What can we do here? Well, I got the same base, right? If I just have that problem right there, I would add those. I would say that's y to the 8 plus 3 over y to the 3rd, which is y to the 11th over y to the 3rd. I only want to have y's in one spot, so my quotient of power property, I rewrite the base, 11 minus 3, and it's y to the 8. This is my final answer. Maybe we saw a shortcut up here before we got to all this. I got y to the 3rd on the bottom, y to the 3rd on the top. If I cancel them, I'm left with y to the 8th. That's it. That's my answer. Okay? But quotient of powers property works right there. All right. You guys try these 2 U tries. Be careful with the negatives. Make sure you shade. Are you starting, getting there, or got it? All right. Now, here's our power of quotient property. Remember, they must have the same base to subtract the exponents. Have to have the same base. Okay? So, when we divide a divided by b all to the m power, it really means a to the m over b to the m. We take this m and we share it. Remember, there's a little 1 there. So 1 times m is m. 1 times m is m. That's my general rule. Okay? Our power of quotients property. All right. Let's do a couple examples. Here's a power of a quotient. X over y is a quotient. Power, I'm going to take this 3 and give it the x and the y. Remember, there's a little 1 with the x and the y. So x to the 1 times 3 over y to the 1 times 3, which is just x to the 3rd over y to the 3rd. Be my final answer. Maybe we're not going to write this step after a while. Just want to show you where it comes from. Okay? Now we got a little bit more going on. So maybe I want to break it up a little bit different. So I'm going to look at the top first. 3x squared, that's over 2x, but it's all to the third power. So this 3 has to go to everything inside. It has to go to the 3, the x squared, the 2, and the x. Sometimes I might write it like this. X squared, all in parentheses, all to the third power. 2x to the third power. Okay? Now I'm going to take this 3 and share it. I get 3 cubed, right? Because there's a little 1 here. 3 times 1 is 3. X squared all cubed. I'm going to multiply that. It's x to the 6th. 2 cubed, just 2 cubed. There's a little 1 here. 3 times 1 is 3. X, there's a little 1 here. X to the 3rd. Okay? Probably clean it up a little bit more. 3 cubed is 27. X to the 6th. 2 cubed is 8. I got x to the 3rd. I'm going to keep going over here. I got x's on the top and bottom. I only want them one spot. So I would actually say 27 over 8. Can I do anything with that? Nope. That stays like that. X to the 6th over x to the 3rd. Well, that's really what? X to the 6 minus 3, which is just x to the 3rd. Or there's 6 on the top, 3 on the bottom. 3 are going to be left on the top. Final answer. All right? One more, then you guys can try a couple you tries. Big problem here. Let's break it up into small pieces. So, I want to make one big fraction about it. 3 times. This m to the 4th is to the 3rd power. This 3 only belongs to what's in the parentheses. So it's times m to the 4 times 3. Over. We bring down the 8m to the 5th. N squared all to the 3rd power. Remember, I got to take this 3 and share it with everything. So it's n to the 2 times 3. We get 3. M to the 12th, 4 times 3, over 8. M to the 5th, and this is n to the 6th, 2 times 3. Okay? Now we want to look step by step. Numbers. Let's see. 3 over 8. Can't do anything else with that. It's going to stay like that. 3 over 8. Let's look at the m's. I got 12 on the top and 5 on the bottom. Well, I could do a little side work here and say m to the 12th over m to the 5th really is m to the 12 minus 5, which is m to the 7th. This turns into 7, right? 12 on the top, 5 on the bottom, 7 are left on the top. N to the 6th stays on the bottom. Okay? You guys, try these 5. Come in with some questions. Be careful about the negatives. Definitely try these bigger ones. Come with questions on Monday. We're going to do one more problem tonight. We're going to write 2 expressions that are equivalent, so the same. They're equal to 4x to the 5th. So 4x to the 5th is going to be equal to what? I'm going to write 2 equations. I'm going to use the quotient rule. So if I had 8 over 2, I know that reduces to 4. Now I'm going to put my x's in there. I got x's on the top, bottom. Well, if I had 10 x's on the top and 5 on the bottom, that would simplify to 5 on the top. 8 over 2 would simplify. So that's equivalent. That's 1. Let's write another one. So maybe we do a product of power. So maybe I say 2x squared times 2x to the 3rd. Okay, well, what does that mean? That means 2 times 2 times x squared, x cubed. Well, 2 times 2 is 4. X squared times x cubed is 2 plus 3, so it's x to the 5th. So that's an equivalent one right there. So see if you're starting getting there. Got it for all these. Come up with some questions, and we'll see you Monday.